Today we're going to talk about the chi-square test a little bit more, but in this particular case we're talking about what's called the chi-square test for independence. So you look at this chart here, and let me just bring some meaning to it. SS, this SS up top means that a student smokes, and SDNS means the student does not smoke. So the categorical variable that we're interested in there is called the student smoking behavior. All right, and then along the side here, these columns that you notice. Okay, so BPS, OPS, and MPS. BPS, this first one here, means that both parents smoke. Okay, so then we could bring meaning to, let me just finish. OPS means one parent smokes, and NPS means no parent smokes. So if you look at this 400, that 400 is telling me that there are 400 students in this school that smoke who also have both parents at home smoking. Okay, and then the meaning of maybe this number over here means there are 1,823 students in this school who do not smoke, but have one parent at home who smokes. That's one parent smokes. And then lastly, if we look at this small number here, there are 188 students who smoke and who come from a home where neither parent smokes or no parent smokes. Okay, so one thing you might be interested in, is there a relationship between the parent smoking behavior and the student smoking behavior? Okay, and first off, you should notice we're comparing what are called two categorical variables. If you're a student in this school, you fit into this category or that category. You either smoke or you don't. And if you have two parents, then they fit into one of these categories. Okay, so we can start to state some hypotheses that we might be interested in. So number one, that there is a relationship between parents' smoking behavior and students, I'm going to give myself a little more space here, and students' smoking behavior. So that's your I'm sorry, I should say there is not a relationship. Usually HO indicates that there's no relationship or anything else, that these two variables are not affecting each other, right? HA is going to be that there is a relationship. Okay? So there is not a relationship versus there is. Sometimes we'll say that parent smoking behavior and student smoking behavior in HO are independent. They have no effect on each other. And HA is that they're dependent, that these two categorical variables actually have an effect on each other. Okay, so to do that, what we need to do is first realize that the table we've been given, this table up here, is observed counts. And if we think about the chi-square test statistic for a moment, chi-square test statistic looks like this. Chi-squared equals observed minus expected squared over expected. Okay, so if we're going to use the chi-square test statistic to see if these observed counts indicate that there is a relationship or not a relationship between these two categorical variables, then we're going to need to get the expected counts. Okay, and it's just a little bit more complicated than what we did in the M&M example. So let me show you a formula that will help us out. So the expected count in a cell, now let me be clear on what a cell is. If you look at this table here, any of these blank boxes here, like this is a cell, and there's numbers that would go in there. Just like in a spreadsheet, you call the little boxes cells. The expected count in a cell is the row total that cell is in times the column total that cell is in, and then you divide by the table total. Okay? So back on this table, what you'll notice is I'm kind of missing what the row totals were and the column totals were. So I'll tell you that if you add these three numbers down, you'll get a column total of 1,004. And if you add these, you get 4,371. And then if we add across to get the row totals, like this, we get the following numbers: 1,780, 2,239, 1,356. We're getting that by adding across to get what are called the row totals. You also probably remember back, we used to call these marginal distributions because we wrote these things in the margin. That's called the marginal distribution of student smoking behavior. This is called the marginal distribution of parent smoking behavior. And then lastly, the table total down in this corner is 5375. Looks a little sloppy, so let's go to a new table and fill these things in. So this, again, this is 1004. This is 4371. And then the table total, 5375. Over here we have 1780, 2239, and 1356. Okay? So now that we have all the totals in there, it'll probably be easier to apply the formula I just showed you. Row total times column total over table total. So for example, if you want to get the number that goes here, we take the row total that it's in, which is 1780, times the column total, well, 1004, and we divide it by the table total, which is 5375. All right? And then if we do the division there, you'll end up getting the following. Well, I'll show you. You'll get this number, 3332.49. Okay? Let's go back to our blank table for a minute. And let's think about, let's say we wanted to know what went in that cell there. Well, they're going to do row total, which is 2239, times the column total, which is 4371. Sorry about writing that so sloppy. Sloppily, I should say. Over the table total, which is 5375. And that's what goes here. Okay? So I can tell you that if you do all of this, you got to do it 6 times, 1 for each cell. You'll get these expected counts. Okay? All right. Probably a good time to check our assumptions. Don't forget your assumptions in the chi-square test. First off, all your data have to be counts. And if we look at our original data set, they sure were. Everything was just a number. It's the number of students in each category. Okay. The next thing you're supposed to check is the population of students in the world greater than our sample size. Well, 10 times our sample size is 5375. There's more than 53,750 students in the world, so we don't have to worry about that. So we have independence. You also want to make sure that all your expected counts are greater than or equal to 5, okay, or at least. And if you look at these expected counts, they're all very large, so we don't have a problem there. And then lastly, this is supposed to be an SRS, so we're going to have to assume that in this case. And I didn't write the assumptions down, but you heard them all. Make sure you address them when you answer a question like this. All right, so now we got to go calculate this. Now I saved us some more time. If we go back to the calculator for a minute and I go to stat edit, what I did was, let's clear out this list for a minute, is in list 3, forgive me, I put all the observed counts. So there's the 400. That's the students smoked with both parents smoke. Okay? Here's the students who smoke. I'll use the large screen here. So that 416 means that's 416 kids the students who smoke with one parent smoking. There's the number of kids who smoke with no parent smoking home. And then there's the second column of the table. Okay? So really, the first 3 entries in list 3 are the first column of the table. I'll show you this. They are these numbers. And then the second 3 entries in list 3 were these numbers. So here we go. We go back to there. And then what I did was I went and looked at the expected count table, and I did the same thing. I made sure that these matched up with the actual counts that we had in list 3. So here we go. We have it now. We have list 3 is the observed, list 4 is the expected. So I'm going to go to the top of list 5, open parenthesis, observed, which is list 3, minus expected, which is list 4. Oops, hold on, a mistake there. Second 4. Okay, close parenthesis. We're going to square that, and then we're going to divide by the expected. So second 4. There you go. We hit enter, and here are all your, I made a mistake. You probably should have caught me. I forgot to divide by expected. Let's do that. Or I did something wrong. Let's see. So open parenthesis, list 3, which is observed, minus list 4, which is expected. Close parenthesis. We're going to square that. And we got to divide it by list 4, which is the expected. That's the mistake. So it's got to be second list 4. Calculator's a little temperamental. So there we go. Those are more reasonable numbers. And you'll notice that first chi-squared at 13.707, that's pretty big. And I'm not really surprised by that because look at the difference between these two numbers. We only expected 332 kids to smoke in a household where both parents smoke if there's indeed no relationship between these two variables. But apparently there is. Notice a small chi-squared where the numbers are close together. Okay, last thing we're going to do is add these up. So we'll do second quit. And then we can sum list 5. It's already done for us. It's 37.566. So now we have chi-squared. Chi-squared equals 37.566. Well, if you went looking at your chi-squared table right now, you wouldn't be able to make any sense of that because well, we don't know what the degrees of freedom are. So, degrees of freedom. In the case of a two-way table where you're comparing two categorical variables, it's always the number of rows minus 1 times the number of columns minus 1. So in our case, our table had 3 rows and it had 2 columns. So if we do that, we're going to have 2 times 1 or 2. There are 2 degrees of freedom for this test. So now it's time to look at the chi-squared table. So here it is. We're going to go to degrees of freedom 2, and we're going to look across. And we'll keep looking for our chi-squared. Let's not forget what it is. Chi-squared was 37.566, I believe, right? Is that what I said? Yes. Okay. And we look across, and we go all the way into the table, and we never get to it. We never get to one that's greater than it. So what does that tell us? Well, it tells us that our chi-squared is so far off the table that it's less than the biggest chi-squared they listed for us. So then we look at the top here, and we notice that tail area of 0.005, that's promising that this area here is going to be less than 0.005. Well, that's what we know then. We know that our p-value is less than 0.0005. And that implies that our chi-squared test statistic is significant. And if it's significant, then we can reject HO in favor of HA. And what that's telling us is that there is a relationship between parent smoking behavior and student smoking behavior, and that these two categorical variables of parent smoking behavior versus student smoking behavior are dependent. Okay? Thanks for watching. Actually, you know what? Before we cut out, sorry, it's a surprise. I'll just pause it. I should show you how to do this on a calculator. It's sort of fun here. So if you go to the calculator, you can actually look over to stat testimony. Go over to test, and in there, you go up, you'll notice there's the chi-squared that in an example or so forth. And if you were to hit enter on that, it would ask you for 2 lists. Usually that's your observed and your expected and so forth. Okay, but in our case, we just have a regular chi-squared test for independence. So you go up to C here, and you hit enter, and it asks for matrices. So you can actually create matrices and do this. So I'll show you how to do that. It's sort of nice. I don't know if it's really any faster, though. It'll tell me. So here we go. You do second matrix, which is that key that has the x to the -1 power on it. You go over to edit. And all we have to do is enter our counts. Now it says 3 here by 2. And when you write a matrix, that's rows first by columns second. And that's what our matrix is. So here we are. And now what we're going to do is enter our observed counts. So we have 400. Enter. And it jumps to the right. So then what do we have here? 1380. Okay. And then 416. And then 1823. And then you have 188. And then 1168. Okay, so there we go. We have our matrix. Okay, you do second quit. If you want to make sure that you did things correctly, you can do second matrix again, and then where it says names, just hit enter. Hit enter again and look at it and make sure it's what you thought. And that's our matrix of observed counts. So all you have to do after you're done that is go back to stat, go over to tests, go up to the chi-squared test. All right, hold on a second. And there it is. Now, you'll notice this is observed. Well, matrix A has our observed. And you might be scared for it. You might be like, wait a minute, I didn't put the expected in matrix B. I got to go do all that table total, column total times row total over table total to get the answer. And actually, you don't. It'll calculate it for you. So you just go to calculate and hit enter. And there you go. And notice, look, there's that chi-square test statistic that we're familiar with, 37.566. And that p-value, it's got an e to the negative 9. So that means there's that decimal place with 8 zeros before we get to 6,959 degrees of freedom of 2. So it's everything we expected. You just have to do that thing with the matrix. Okay, this time I say goodbye for real. Thanks for watching.